Here we are in section 1.3, ready to take off. And so here we go. The first group of problems asks us to solve the equation by factoring. And so it's all the same general rules, just follow the process over and over again. We have 39x squared plus 27x equals 0. Now the first thing, we need to get everything to one side and set it equal to 0, and then we start factoring. I look at this and I can factor out an x, which leaves 39x plus 27. Then I can set each one of these equal to 0 and then go ahead and solve. So x equals 0, as does 39x plus 27 equals 0. Subtract 27 from both sides and divide both sides by 39 and simplify, and we get negative 9/13. Number 2, x squared minus 4x minus 32 equals 0. It's already set to equal to 0, so we don't have to do anything there. But then we can immediately start factoring, and if we look at this, this is x minus 8 times x plus 4. And setting each one of those equal to 0, x minus 8 equals 0, or x plus 4 equals 0. So that means x would equal either negative 4 or x might equal 8. Continuing, example number 3. We have x times the quantity x plus 4 equals 32. Now the first thing we have to do is get 0 all by itself. So what we really have to do first is to FOIL this or distribute this out, and we get x squared plus 4x equals 32, and then subtract both sides by 32 so that we get 0 on the one side. Now this becomes relatively easy to factor because this would be x plus 8 and x minus 4. X plus 8 equals 0, or x minus 4 equals 0. So that means x might equal 4 or x might equal negative 8. For number 4, we get 18x plus 16 over x equals negative 36. First thing, get everything to one side and set it equal to 0. So this would be 18x plus 16 over x, adding 36 to both sides, we get that. Now get rid of the fraction. Well, common denominator is x, so multiply everything through by x. 18x squared plus 16 plus 36 x equals 0. And writing this into a much more user-friendly version, 18x squared plus 36x plus 16 equals 0. Now, first thing I see is I can factor out a 2, which leaves 9x squared plus 18x plus 8. Then, this will factor, and if you need a way to factor these types of problems, you are certainly allowed to use the tic-tac-toe method, which is on my website. You can read that, or if you would like, I can go through that process in class as well. And then we can set each one of these factors equal to 0. Well, obviously setting 2 equal to 0 isn't going to do any good. So I can do 3x plus 4 equals 0, or 3x plus 2 equals 0. Solving this one, subtract 4, and then divide by 3. X equals negative 4/3. Likewise, subtract 2 here, and then divide both sides by 3, and we get that. Examples 5 and 6 asks us to use the square root method, which means we're going to be using square root at some point. preliminarily, or as an intermediate step, what we need to do is we need to get x squared all by itself. So in this case, all we'd have to do is add 2. So x squared would equal 2. And then once we get to this point, we can take the square root of both sides. Square root of x squared is x, and when we take the square root of this side, we have to remember to take the plus or minus of both of them, the square root of 2 in this particular case. Now I said get x squared all by itself. We need to get something squared, some expression squared, and then we can take the square root of both sides. For example, if we look at example number 6, we have the quantity 4x plus 2, the quantity squared, equals 36. Now we have something squared equals 36, which means we can take the square root of both sides immediately. And so we get 4x plus 2 equals plus or minus the square root of 36, which is 6. Then I can so now that I have two separate problems here, so I'm going to split them up into their two separate problems. 4x plus 2 equals 6, or 4x plus 2 equals negative 6. And then treat each one of these as separate problems. Subtract 2 from both sides, and divide both sides by 4, x equals 1. Subtract 2 from both sides here, and divide both sides by 4, x equals negative 2. So our possible answers would be 1 and negative 2. And it is important to realize that in the overall scheme of things, we do want to check each and every one of these equations, and you can always put the answers we get back into the original, and it will actually give a true statement. Problem number 7 starts in the completion of squares, or completing the squares, and we are asked specifically, what do we have to add to this to make it a completion of the squares, or completing the square? Now anytime we are asked to complete the square, the process is the same. We're going to take this x term, or the linear term here, the linear coefficient, and what we're going to do is we're going to divide it by 2. So we have to take 3/5 divided by 2, which will equal 3/10. Now that's the first step. The first step is take half of what's here. You don't need to worry about the sign here. It will, because we're always going to add something to it. Now what we do to this is we're going to take that value and then square it. So 3/10 squared becomes 9/100. And this is the answer. What do we have to add to this so that it becomes a perfect square? It would be 9/100. Now how we use that is, this is yet another method of solving equations, and that is by completing the square. So if you are asked to complete the square, the process is a little bit different, and so you need to be aware of those. First thing you do, get all the x's to one side and the numbers to the other side. This is different than what we've looked at in the past. So it'll be x squared plus 4x will equal 3. And notice I'm leaving a little bit of space here, because this is what we're going to do to complete the square. Now remember how to complete the square. We're going to take 4 divided by 2 is 2. Then what we do to this number is we square that. 2 squared is 4. So we're going to add in 4. But to keep things equal, we need to add in 4 on this side as well. And so what we get, the purpose of completing the square is so that this becomes factored to the x plus 2 quantity squared equals 7. Now where'd this 2 come from? This 2 is that half number there. And if we would actually FOIL this out, we would realize we would get x squared plus 4x plus 4. Or a better way to look at it is, this is the factored form. This right here is the factored form of this. Now since we've got this, all we need to do is take the square root of both sides right now, because we have something squared. That means we can take the square root. That's the whole point of completing the square. So it'll be x plus 2 equals plus or minus the square root of 7. And then To solve for x, all we have to do is subtract 2, so that x equals negative 2 plus or minus the square root of 7. And there's the answer for number 8. Example number 9 is x squared plus 5x minus 5 equals 0. Same directions, complete the square. So I need to get x's on one side, everything else to the other, and leave a little bit of room. So I'm going to take half of that, 5 halves, and then square it. 5 halves squared is 25 fourths. So that's what I need to add in, is 25 fourths to both sides to keep everything equal. So factoring this would look like x plus 5 halves. It's half of that factor, right? Or half of that right there. And then 5 plus 25 fourths would be 45 fourths. Now we can take the square root of both sides. So x plus 5 halves equals plus or minus the square root of 45 fourths. Now this becomes plus or minus, okay, let's see, what can we do? We can do 3 square root of 5 all over 2. And so we get x plus 5 halves equals plus or minus this. So then all I have to do is subtract 5 halves from both sides, so that x equals negative 5 halves plus or minus 3 root 5 halves as well. And then the final example for this particular video is example number 10. 3x squared minus 2x minus 4 equals 0. And one thing, in order to complete the square, we basically need to have the x squared all alone. So the very first thing we have to do is divide through everything by 3 to get rid of this 3 right here. So there'll be x squared minus 2/3 x minus 4/3. Now get x to one side, everything else to the other side. So that'll be x squared minus 2/3 x, leave a little bit of room, 4/3, and we're going to add the same thing here. So we take half of 2/3, which is equal to 2/6 or 1/3. Then we need to square 1/3, which is 1/9. So that's what we're going to add here, and that's what we're going to add over here. So this becomes x minus 1/3 quantity squared equals, and this becomes what, 13/9. 4/3 plus 1/9, I do believe, turns out to be 13/9. Then take the square root of both sides, so that x minus 1/3 equals the square root of 13 over 3, plus or minus, because we need to have both of them. And then finally, adding 1/3 to both sides, x would equal 1/3 plus or minus square root of 13 over 3.